Good afternoon, everybody. Thank you for joining us. We'll be getting started in just a couple minutes.
Good afternoon, everyone. Well, thank you for joining us for today's presentation, looking at the performance-based compliance paths for Ashrae 90.1 2019 version and the 2018 version of the International Energy Conservation Code. Today's session, I'm joined by my colleague Sean Maurer, and the session is anticipated to go approximately an hour and a half, so we should be wrapping up here at 2:30. If you do have questions as we go through, please feel free to go ahead and put them down below in the question and answer function towards the bottom of your screen. Today's session is being recorded, and the recording along with the PDF of today's slides will be posted to our website following today's session. So be looking for that. Today's session does have some continuing education credits. Along with that, looking at some of our learning objectives and what we're looking to cover today, understanding some of the organizational differences between Iecc and Ashrae 90.1. We'll be touching on a lot of the different differences and similarities between the performance path requirements, along with what to look for in our models, and for verifying the models, what you're going to be looking at as far as what should be the same and what should be different in those. So, as noted, we do have continuing education credits. We are a registered provider for Iecc along with AIA. Everyone will receive a certificate of participation for today's session. So if you do need continuing education credits for self-reporting, of those credits, that certificate will be available. Along with that email, if you do need ICC or AIA credits specifically, there will be a link to a form that you can fill out showing your registration, and we can get that recorded and reported for you. A little bit of background about who we are. We are housed at the University of Illinois down at Urbana-Champaign, along with our colleagues at the 360 Energy Group up in the city of Chicago. And our primary mission is to reduce the energy footprint of Illinois and beyond. So energy code compliance and training is one of the programs that we use to accomplish that mission, both in the public sector and the private sector. I do like to thank our sponsor for today's training program, provided in part by the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency in Springfield. So we do like to recognize them for making today's session possible. We do provide technical support for any projects located here in the state of Illinois. That can include people such as the design professionals, code officials, building owners and occupants, and the like. So if you do need some technical support as far as compliance with or understanding the Illinois Energy Conservation Code, feel free to reach out to us, energycode@illinois.edu. We also do have an 800 number, so if you do have a real quick question, feel free to reach out to us, 800-214-7954. But we do prefer questions to come in through the email, so that way we can provide you a written response that you can provide to other people that are affiliated with the project, and also to be able to provide you a more thorough response with that. So we do have several online resources at our website shown here, smartenergy.illinois.edu/energy-code. Some of those include archive versions, along with announcements of upcoming workshops and webinars. We do have several online courses, online on-demand training. These take approximately an hour to an hour and a half and cover a range of topics. Some of the more common ones or more popular ones being on Manual J, as well as residential provisions. We also do link back to our technical support hotline. So again, if you forget the phone number, you can reach it there. We also do have several other available resources, including some information about the Illinois Energy Conservation Code, which is based on the International Energy Conservation Code. Several frequently asked questions, particularly useful if you have questions regarding low slope roofs. We have a lot of questions about those. So check in the frequently asked questions, along with links to several useful websites. Some of those include links over to the International Energy Conservation Code, again, which is the basis of the Illinois Energy Conservation Code, links over to the amendments for the Illinois Code, along with the City of Chicago's Energy Conservation Code. The International Energy Conservation Code is the model code that we use, which is then amended by Illinois and then potentially further amended by local municipalities such as the City of Chicago. So rather than trying to remember the big long web address, again, feel free to come over to our website. So, today we're going to be focusing on the 2019 version of Ashrae 90.1. Ashrae does make available free preview versions of their standards. The International Code Council also provides free preview versions of their codes. Again, providing a web address here for that. And also understanding that the 2018 International Energy Conservation Code is the referenced code for the State of Illinois Energy Code, which references the 2016 Ashrae 90.1 by reference. So we're actually going to be covering the 2019, which is the referenced version of the upcoming 2021 International Energy Conservation Code. A question that we do frequently get as far as when will Illinois be moving from the 2018 to the 2021 version. At the present time, it is slated to move June 1st. So permits applied for before June 1st would likely be on the 2018 version of the International Energy Conservation Code. Permits applied for June 1st or after will likely be on the 2021 International Energy Conservation Code. Those dates may shift a little bit as we approach that. They are still continuing to make their way through the amendment proposal process, but at this point in time, June 1st is the date of the changeover for Illinois at the moment. So understanding energy code compliance and how these are different. The International Energy Conservation Code is written as a code and adopted as law. So Illinois has adopted the International Energy Conservation Code as the model for the Illinois Energy Conservation Code. And then as part of the Iecc, Ashrae 90.1 is a standard that is referenced in the code. So what that allows you to do is you can comply or demonstrate compliance with the energy code by one of two things. You can either use the Iecc to demonstrate compliance, or you may use Ashrae 90.1 showing that you are compliant with the provisions required. We do note here that you can't cherry pick, so you cannot, projects may not use a combination of both to demonstrate compliance. You may use provisions from both, but compliance must be demonstrated using one or the other. An example would be you cannot use the Iecc envelope provisions along with an Ashrae 90.1 lighting system. Has to meet all the provisions of one or the other. So today is the last of the ones for this calendar year for workshops. Here we are listing some of our upcoming workshops for the new year. In January, looking at energy code testing and verification. February, focusing on the envelope. Mechanical coming in March, and lighting and electrical in April. So if you are interested in signing up for any of those upcoming workshops, again, feel free to visit our website. And along with those workshops, we do have a few webinars coming up, looking at some lessons learned in February, lessons learned by the City of Chicago, air leakage and blower door testing coming in March, and the Iecc or Illinois Energy Conservation Code updates at the end of May. So that will be presented shortly before the new updates will take effect June 1st, or slated to take effect June 1st. So we will continue to post updates to our website as well as our newsletter regarding the upcoming changeover to the 2021 Iecc. So be looking out for that. So as I noted earlier, you have two paths to demonstrate compliance with the Illinois Energy Conservation Code. You can use the 2018 Iecc or the 2016 Ashrae 90.1 to demonstrate compliance. Today is a little bit of a preview showing some of the 2019 Ashrae 90.1, which will be the alternative to the upcoming 2021 Iecc. So, a little bit as far as how these are organized in the structure of the code. So the Iecc has a section for total building performance, section C407, and then that will refer back to a few provisions that are mandatory back in earlier sections of the envelope, mechanical, service, water heating, and electrical. Ashrae 90.1 has two different energy paths that you can use for performance. The first being the energy cost budget method, and the second being the performance rating method, also known as Appendix G. So commonly we'll see Appendix G compliance for projects that are pursuing LEED rating system, but either path can be used in Ashrae. So for performance, we actually do have 3 different paths that you can choose to demonstrate your compliance under a performance-based method for commercial construction. So here's a brief look as far as what that cost budget path consists of. So section 11, you have your general requirements, and then it will refer back to some of the required sections earlier in the code, and then your general simulation requirements, calculating what the energy cost versus the budget is, and then documenting compliance with that you have met the standards. So with that, let's do a quick poll here, learn more about your familiarity with Ashrae 90.1. So first question is, have you used or seen the 90.1 compliance options, yes or no? And how comfortable are you with Ashrae 90.1 versus the Iecc? Do you definitely know the Iecc better, about the same knowledge level for both, or definitely know 90.1 better? Give that just a few moments here.
Okay, looks like we've got most of our responses in, so we'll share those results.
All right. Well, that is good that the majority of our respondents here are have used and or seen the 90.1 compliance options. And the majority of you do feel that you know the Iecc better, which is not uncommon. We do see that the Iecc compliance paths are chosen a little more frequently than Ashrae 90.1, but good to sort of have a baseline understanding of where you feel you are. So thank you so much. And with that, I'll turn it over to Sean to start talking about some of our general compliance comparisons.
All right, thank you very much, Ryan. So getting into our general requirements, by and large, the Iecc and the Ashrae's performance path layouts have the same general requirements. But this is one area in particular where they do have a significant difference. For the Iecc to demonstrate compliance with your performance model over the reference design, it has to have at least 15% less energy cost than that reference design in the Iecc. Where Ashrae, you just have to have less energy cost than your reference design. They don't have that 15% requirement. The reason being, in the Iecc, it has that section 406 additional energy efficiency options that push you a little bit more beyond just those prescriptive requirements that are in the code. And so they add that in with this 15% less energy cost requirement. Just some another slight difference between the two. Iacc has specific sources for energy costs listed in the general requirements that Ashrae leaves kind of general, just says whatever's acceptable to the authority having jurisdiction. In practice, these are going to end up being about the same for both most cases. But it is a little bit of a difference there in that the Iacc does have specific resources for energy costs listed. Both Ashrae and Iacc do require verification of software used for modeling purposes. So in both instances, they have to be in compliance with Ashrae Standard 140, which is just a standard program for evaluating building energy models, sets up requirements for them in terms of hourly simulations, how accurate they have to be with a reference model, And so this requirement is similar for both the IECC and Ashrae. It's listed in both the general requirements. Getting into a little bit more detail, moving into some of the specific requirements. Looking at on-site renewables, the IECC has allows for reduction in your energy cost model of a 5% from renewables, which is matched by Ashrae. So you can't, if you're looking at a model trying to go net zero through renewable energies, um, these specific programs don't allow you to take more than that 5% credit. Appendix G, however, as we're noting here, doesn't have that 5% limit. So they let you take a little bit more credit for your renewables all the way down to net zero energy. Uh, Something else to note is that IECC references on-site renewable energy, while Ashrae spells out what the on-site system is in specific terms. It either has to be owned, leased, or contractually supplying energy to the building owner, where the IECC just states on-site renewable energy. Um, if you go into the definitions in the IECC, there's more information there that indicates about the same definition for on-site renewables as the Ashrae program. Um, but what you're looking at here is that if you're taking the cost performance path, Ashrae and IECC are very similar. If you're looking to take more advantage of your renewables, then you're going to be looking for the Appendix G compliance option. Electric vehicle energy use has the same requirements for both IECC and Ashrae. They exclude any energy consumption for refueling or recharging vehicles that are for on-road use or off-site transportation. Uh, if those vehicles are something that is used on the site specific to that facility, usually it would be something like a tram or something like that, then that energy would be included in the energy consumption of that building. Uh, the only place where I would think you would really see something like that is sometimes you see trams for airport transition through different terminals. That kind of energy consumption would be site energy consumption. What they're trying to avoid here is energy for charging up vehicles that isn't used at the site of the building. It's not for the purpose of the building's energy consumption. And so those do not get modeled when you're modeling facilities for performance cost path. The next section, the exceptional calculations. These are calculations where your modeling software isn't able to model a specific component of your facility. It could be an advanced HVAC system, or if you've got a specific wall assembly that might not be one of the default models that's built into the modeling software that you're using. Uh, these systems or calculations are usually done in an external spreadsheet and then added into the model to show their impact outside of the energy model itself. So there are specific requirements for those in the IECC and Ashrae. IECC keeps the requirement for these exceptional calculations fairly simple. Their impact on the energy cost difference between your reference design and proposed model cannot exceed 50% of the difference between your energy costs. So the savings between the reference design and the proposed design, 50% of that can be exceptional calculations. While a bit simpler in requirement for buildings that are minimally better than the reference design, if you're hitting right at that 15% improvement, then you're only able to use 8.5% of your energy savings through exceptional calculations. Ashrae does not place a specific limit on the amount of the exceptional calculations that can be attributed between the proposed and reference designs, but it does require something that the IECC does not for those calculations, and that is sensitivity analysis that shows how much impact slight variations in actual practice from your design those exceptional calculations are going to have on the actual building's energy consumption. So the IECC does not requirement, the Ashrae does have that requirement. The way they do that is for the sensitivity analysis, whatever your exceptional calculation is, you have to take the variable that's associated with that calculation and double it and half it from its design value, and then show the impact that that has on the building's energy consumption. So it's a little bit of extra work for exceptional calculations in the Ashrae model than the IECC, but you have a little bit more flexibility in application for those calculations. So we have another poll question here that we will launch. The first question, in Ashrae and IECC, do they both require the proposed design to have a 15% energy cost reduction than the standard reference design? And then for both Ashrae and IECC, do they exclude electric vehicle charging for vehicles used off-site? Don't see that we've had any questions come into the chat or Q&A. If you do have questions, please put those into the question and answer box throughout the presentation. We'll answer them as we are able or at the end of the presentation. Okay, looks like we have most of our responses in, so we'll go ahead and share those results. Looks like the grand majority of people got them correct. The first is a false statement. Ashrae does not have that 15% energy cost reduction that the IECC does for its requirements. And they do both exclude electric vehicle charging from their energy use consumption. So nicely done. And now I will hand it back to Ryan to go over kind of a comparison of the mandatory requirements and how those will impact the energy models.
Well, thank you. The IECC goes through and it enumerates in the performance path the mandatory sections directly. So it will go through and provide a listing. There is more than 14 different mandatory provisions throughout the IECC that do need to be adhered to regardless of your compliance method, whether you're using a prescriptive path, including the UA trade-off, or one of the performance paths. Ashrae handles this a little bit differently in that rather than referring back directly to the applicable provisions, it has a reference back to each chapter's section, which then lists the mandatory provisions within that section. So there's kind of a two-step process here for Ashrae 90.1, where rather than IECC, which is a direct reference back, which can be a little bit more straightforward. So Ashrae, it's pointing back to each individual section, be it lighting, plug loads, et cetera, et cetera. So with each one, how they deal with the mandatory air leakage requirements, the IECC is fairly similar to Ashrae in that only the mandatory provisions are for the envelope sealing. Something that we call out is, given the importance of making sure that your building is tight, controlling that air leakage, and because it also carries with it associated humidity transfer, and how we're tying the air leakage requirements to the specific method. So there is some flexibility as far as how you're going to meet your air tightness targets and insulation levels, but some of these are not mandatory that are providing some flexibility. Also noting that Ashrae does have some much more specific requirements for the air barrier subsections, and Ashrae does require testing and commissioning of the air barrier, which makes sense because as we are going through, we commission a lot of our systems. You go through and you have your lighting system commissioned and your HVAC, understanding that these are fairly complex systems and have become ever more complex. And so by including the requirement to commission the building envelope, understanding that building envelopes have become much more complex systems than they once were. And so that's where the criticality of making sure that we're commissioning this is very important. Ashrae noting that if you are within a range where you didn't quite meet your 0.4 CFM per square foot target, then you can meet compliance through some additional commissioning and sealing of that envelope. Whereas Ashrae also has a little bit more detail as far as the vestibules language is a little bit more specific in Ashrae. Iacc has a little more vague requirement, only stating that the doors should not be opening simultaneously, such that your vestibule is long enough that you don't end up with both doors being open. Ashrae also adds some requirements for semi-heated spaces. This is a space category that is not found in Iecc and maybe more common for like warehouses that you are not trying to provide full comfort conditioning and only providing some minimal conditioning just to keep the chill off. So initial modeling may not be impacted by this semi-heated spacing requirement, but the final adjusted model would be adjusted to match the building construction to verify that compliance has been achieved. For ventilation, there's a fair bit, there's a slight difference here in the approach that the Iecc and Ashrae take for compliance. Iecc tries to reference the ventilation standards where needed and where they interact that energy model, whereas Ashrae relies on enforcement outside of that standard rather than mandating it within. Common practice is both Ashrae and Iecc compliant buildings do have or do meet ventilation standards. It's just Iecc specifically states you shall meet Ashrae standard 62.1 by reference of the International Mechanical Code, whereas Ashrae understands that common practice is to go ahead and use that Ashrae 62.1 to demonstrate that compliance for ventilation. So, fan efficiency, this is one area that is quite different between the two. The Iecc uses the fan efficiency grade, or the FEG, whereas Ashrae uses the fan efficiency index, or fan energy index. The fan energy index is a much better model and a much better measure of the total fan system efficiency. Rather than just looking at the fan, it's actually looking at the entire system. So that includes things such as your motor losses, your VFD losses, and accounting for different size fans that may go within a specific housing. So these may all have the same fan efficiency grade, but have dramatically different fan energy indices. And so here we're looking at one table here, the fan efficiency grades. Several of these may have the fan efficiency grade of 71, but we see there's a dramatic difference based on what belts you're using, what model, what size motor. 71 could have a fan efficiency index 1.7. Some of these are 1.4s. Quite a dramatic difference. So understanding that there is a difference, and when you're specifying your unit, understanding what you're looking for to make sure that you are meeting that requirement. So, as far as service water heating, Iecc has requirements. Nearly all of these are mirrored across Iecc and Ashrae. However, Ashrae does exempt some of these larger 140 gallons or bigger storage tanks with some additional insulation and meeting some specific requirements. So something else that the Iecc that we're calling out here is Iecc does have some additional efficiency requirements for larger gas-fired service water heating systems. So if you're getting over 1 million BTUs of service water heating, commonly these might be found in like larger multifamily residential buildings and perhaps some larger commercial and institutional buildings that may have water heating over 1 million BTUs an hour. Service water heating traps. This is one where Iecc and Ashrae, again, fair bit of overlap between these two. Iecc does exclude solar water heating systems. So this is particularly notable as far as understanding that the Iecc looks at solar water heating as renewable energy. And so that's not, if I lose some of that renewable energy, that is not as detrimental to society as if I'm losing some of the heating off of either electrically powered or gas-fired equipment due to all the emissions involved. So also Iecc does have some notes as far as the heat traps, and Ashrae also covers that we do need to have heat traps on vertical piping entering and exiting this water storage tank. And understanding that the piping thermal losses would not necessarily be modeled. The difference in the piping losses that we're calling out here in Iecc, because they're going to be the same in both, it's not a dramatic difference there. So something to be aware of is if you do have high efficiency service water heating equipment, then that standby loss and pipe loss may play a factor in that. So, as we're looking over to service water temperature requirements, again, most of these are matched across Iecc and Ashrae. Iecc does not have required controls for the storage temperature adjustment, as we see here Ashrae does. So again, Ashrae is modeling, adding a little bit more complexity. This is part of the reason why, for those of you who have encountered both Ashrae's document as well as the Iecc, the book is a little bit much thicker for the Ashrae, because they do try to be a little bit more specific about certain aspects of things. But again, the actual impact on the model is not going to be very dramatic. However, it is important to note that these requirements do not supersede those that may be found in the Illinois Plumbing Code, particularly regarding temperatures for anti-scald. So there may be some additional requirements in the plumbing code that are not covered here in the energy codes. So, lighting is another area that we have a fair number of different requirements for mandatory, and understanding that most of this is covered both across Ashrae 90.1 and Iecc. So there is a correlation between most of these. But there are a few that are in Ashrae that are not in the Iecc. Ashrae does have a little bit more detail as far as partial lighting controls, more so than Iecc, which is more focused on just bi-level and daylight harvesting controls. Ashrae also has both primary and secondary daylit zones. whereas IECC presently only has the primary daylit zone. IECC also just states that the light reduction controls must reduce power by at least 50%. And so the light reduction controls could go down to 50% level, or it could even go to fully off, because that is at least 50%. However, Ashrae does have a requirement for an intermediate step. So there must be an intermediate step that falls between 70 and 30% of the full amount, or continuous dimming is perfectly fine as well. But there must be at least one spot in there that you can turn the lights down to somewhere between 30 and 70%. For the purposes of modeling, this could impact the complexity of some of your lighting schedules, and Ashrae may make them a little bit more difficult to estimate using those controls. However, these controls are the same between both models. So being aware as far as what impact that may have, it may impact both your baseline and your proposed model in the same fashion. So predominantly how your model is going to be impacted is if you're going to be able to reduce your lighting power density. That will see a dramatic change between the two. With that, I believe we've got another poll here. And that is, how do the exceptions for standby loss impacts Ashrae versus IECC in the energy cost performance? Ashrae can have more energy loss for hot water. Ashrae can have less energy loss for hot water. Ashrae can allow designers to take advantage of the decreased standby loss in the proposed model, increasing savings, or there is no relative impact.
Did have a question come in for the last section regarding exceptional calculations. The question was, do the exceptional calculations include settings that are programmed on top of the compliance software but run within that simulation, or only analysis done outside compliance software? The exceptional calculations would apply to any calculation that you're doing outside of your compliance software. If you're running programming inside the compliance software, it does have to comply with that Ashrae 140 document, but that is within the compliance software, and so that is not considered an exceptional calculation because it's being done by the software. What they're trying to limit with the exceptional calculations limitation is a lot of calculation outside of a standardized based compliance software system. So most of our answers are in for our poll. The correct answer here was that Ashrae can allow designers to take advantage of decreased standby losses in their proposed model, increasing the modeled savings. It goes back to the slide where we were discussing the standby loss in Ashrae. They do account for those standby losses more than the IECC does, but they do not account for pipe losses. Ashrae does focus on that standby loss where the IECC does not. Okay. So now we'll move into direct comparisons of that standard design and reference design requirements for the IECC versus Ashrae. Both of Ashrae and IECC have a table of requirements for what's in the standard reference design building and what's in the proposed building model. As you go through the table, a lot of them will say these requirements are the same, but there are specific areas that have differences between that proposed design and the reference design that we want to call out here and just see how those compare between the IECC and Ashrae. The first one is envelope opaque assemblies. The IECC has specific construction assemblies that are required to be used regardless of what's used in the proposed design. And so the IECC's standard reference design has to have above deck insulation for roofs. You have to use mass or steel framed walls for commercial facilities. If you're using mass walls for your foundation, it has to have interior insulation. Your floors have to be joist framed, and you have to use unheated slab on grades for your standard reference design. Your proposed design can use exactly what you're using. Ashrae lets you directly model in your reference design what you're also doing in your proposed design and just account for the insulation differences between the two construction or assembly types. So you get a little bit more of a direct comparison with Ashrae than you do with the IECC, where the IECC is building kind of this specific most common reference model. The Ashrae is doing more of a direct comparison between your opaque assemblies. The impact this can have can vary a little bit. So the IECC, again, you've got much more restriction on that reference design for what can be in that reference design. That can kind of falsely increase your energy savings a little bit, depending on your assembly types chosen. As an example, if you've got a wood framed commercial building, and you're limited in your reference design to having those steel framed walls, then you're getting a little bit more energy savings because of that thermal bridging that isn't there in the wood framing that is in the steel framing. So you get a little bit of an increase in savings between your standard reference design and your proposed design for the IECC, where the Ashrae doesn't have that. They would both be wood framed assemblies. Similarly for foundation requirement, just as another example, since the IECC requires interior only insulation, it removes the ability for the model to project the impacts of that thermal mass, where with Ashrae, if you're using exterior insulation, both models would have exterior insulation on them. And so IECC, you get a little bit more benefit if your proposed model has that thermal mass within the insulation layer, where Ashrae, again, you've got that more direct comparison between your two building designs. We just had a question come in. Ashrae does not apply for wood frame assembly. It does apply. It's just that in the IECC, your standard reference design, if you're using a wood frame for your proposed model, the IECC requires the reference design to have steel framing. For Ashrae, both would have wood framing. If they were both steel framing, then Ashrae would both have steel framing. So it's just that Ashrae is that direct comparison of your assembly types, where IECC has some specific assembly types for the reference design. Moving on to fenestration requirements. The IECC and Ashrae both cap your fenestration for the standard reference design. For the IECC, it's a 40% window to wall ratio. For Ashrae, you're referencing back to your climate zone tables, which for climate zones 4 and 5 in Illinois is also a 40% window to wall ratio. If you exceed that 40% window to wall ratio for your proposed design, the IECC just states that your reference design model is capped at that 40% window to wall ratio. The Ashrae puts a little bit more of a requirement on that, in that you have to proportionally decrease all the different orientations of the walls until that 40% window to wall ratio is met overall. What this allows for is that in the IECC, you can have a little bit more manipulation over what sections of the walls your reference design is reducing for that 40% window to wall ratio, since there isn't that specific requirement for how to reach that. But best practice for modeling is that you would do a proportional reduction, like is what is required in the Ashrae model. But again, this is another way where you can get a little bit more energy savings noted in the reference design for the IECC than you would get for the Ashrae, with that kind of more direct comparison of your window areas. Moving on to interior lighting requirements. For the Iecc, if you have an unknown occupancy classification, it's going to specify in the model you have to have a 1 watt per square foot lighting power density if you don't know what that space classification is going to be. Typically, you see this for strip malls where you don't know if it's going to be a store that might have refrigerated equipment in it or a clothing shop or something like that. Might impact the difference in those lighting power densities. Uh, But for both models, in Ashrae and Iacc, the lighting power density in your standard reference design is going to match what is in your proposed design. I'm sorry, your standard reference design is going to match what's in the minimum requirement tables, and then your proposed design is going to have your actual proposed reduced lighting power densities. And so these wattage requirements are going to be what are required for the reference design, not what's in your proposed design. For Ashrae, it does specify a 0.6 watt per square foot for dwelling units that's not in the Iecc for your reference design. Again, your proposed design can be less than that. When it comes to modeling the controls for lighting, those lighting controls are the same between the reference design and the proposed design. So as we noted earlier, for Ashrae, it adds a little bit of complexity to their controls requirements that does have an impact on the scheduling that might be added to the model in order to make it accurate. But since they're the same between the proposed design and the reference design, it doesn't have a lot of impact on the output of the model. And so we do see sometimes that people lean towards the Iecc because it's simpler to put in those lighting schedules, where the Ashrae does have a little bit more complexity without getting a lot of bang for your buck for having to do that additional modeling. Looking at thermal zones in the Iacc versus the Ashrae, for the Iacc, all the requirements that are in the Iacc are mirrored over to the Ashrae requirements. So your proposed design and your reference design have to match in that the zones that are in your reference design are mirrored over to the proposed design. So this does allow, when you're looking at these thermal zones, since Ashrae has 2 additional requirements, it can add more zones to the model, which will add a little bit more complexity again to that model. But in this case, you may be able to get a little bit more benefit in the Ashrae model, depending on orientation of the building. Having more zones in the model, you can have a little bit more interaction between envelope features, like if you're trying to maximize daylighting or take advantage of thermal massing. Zones that are oriented to the south can be broken up a bit more. Where the Iecc, they all kind of get lumped together, and that energy interactions between those zones kind of get blended across a larger thermal block. And so while Ashrae does add a little bit more complexity in the requirement for the zones, it does give you a little bit more ability to have zone interactions that can net you a little bit more savings between your reference design and your proposed design than the Iecc, where those zones get blended together. Looking at refrigeration equipment, this is a pretty significant difference. The Iacc treats refrigeration equipment as an internal gain in facilities. It doesn't have specific requirements for refrigeration equipment spelled out in the reference design versus proposed design tables, where Ashrae does. Your proposed model, if you're using AHRI 1200 equipment, then you use that in your proposed model, where your reference design is going to be different in that it's using the table 6.8.1-11 efficiencies and capacities. And so it does have the ability again here, where Iecc, these internal gains are the same between models. Ashrae gives you, for a little bit of sorry about that. Ashrae adds a little bit more complexity to the model for modeling this refrigeration equipment, but gives you a little bit more energy savings potential between your standard design and your reference design for that trade-off. For Ashrae only, these requirements are not, or these options aren't in the Iecc. For HVAC systems, for the most part, you are matching controls and things across your HVAC systems. But Ashrae does include some additional notes on fan speed control that are not in the Iecc. Fans in the reference design are modeled as 1 or 2 speed fans only. So they simplify those down in the reference design. And then your proposed design can have variable speed fans. So this is kind of a trade-off the other way, where usually the Iecc is going for a simpler reference design model. And then your proposed model matches what your actual design is. Here, Ashrae has gone that route with their fan systems. So Ashrae is going to give you a little bit more savings on fan systems when you're using variable speed controls than the Iecc would, as the Iecc, both your standard design and your reference design would have variable speed fans in them. Also, the Ashrae tables do include economizer, high limit shutoff, and cooling tower leaving temperature set points that the Iecc does include, but they're in footnotes to the table, and they're not as complex as the Ashrae is. Again, Ashrae's taking that more detailed approach to modeling, trying to make that model as accurate as possible, where Iecc is making some simplified assumptions. For the Iecc, the HVAC system mapping. So depending on your system types that are in use in the building, the reference design has a baseline system type that gets modeled for it. It has a separate table of these that Ashrae does not have included with it. That helps you select between your ground and water condenser types, or an airborne, or air-cooled, or no condenser for your cooling source. So the Iecc does add a little more clarification here on when to pick these different condenser types that the Ashrae has left off. But again, with the Ashrae model, your reference design, your proposed design have the same system modeled in them. The Iecc, again, here is that reference design is going to have specific limited types added to it to simplify that reference design model, which will give you a little bit more savings than what the Ashrae modeling will have, where you have that same specific system in both your reference design, and you're just accounting for the efficiency increase. The nice thing for the Iecc too, though, is that it's specifying specific things to get modeled, where the Ashrae leaves those a little bit more vague. There are also some clarifying notes in the standard reference design HVAC section as far as the system type, whether it's going to be a single zone residential, non-residential, or other, which would be all your other multi-zone commercial systems, and how to select those. So again, the Iecc has taken this simpler reference design model. You're getting a little bit more energy savings because of that out of that reference design than you would for Ashrae, where you're modeling the same HVAC system in both your reference design, your proposed design, and you're just accounting for those efficiency increases. We do have one more poll here before we just do a bit of a wrap up on what we've reviewed so far. So which of the following has an impact on the model's complexity, but not on the relative savings between the standard reference design and proposed design? The 40% window to wall limitation for the reference design in Ashrae versus the Iecc, assembly construction, or modeling that refrigeration equipment. Doesn't look like we've had any further questions come in. looks like most of our responses are in. We're a little bit split here. The correct answer was modeling of the refrigeration equipment in Ashrae versus the Iecc, which looks like most people caught that as we went through. But that 40% window to wall limitation, since the Iecc doesn't specify how you do that reduction, you can get a significant difference between your standard design and your reference design. Uh, in Ashrae, with a proportional reduction, it does still have an impact on your reference design versus your proposed design as you're doing a reduction on all the facades of that window area. So that's going to decrease the energy consumption slightly for your reference design. Um, similarly, we caught for the assembly constructions, we went over a couple of examples where the Iecc requirements will have some different impacts that you can take advantage of that the Ashrae model doesn't let you take as much advantage for. But that refrigeration equipment, Ashrae requires a little bit more modeling, where Iecc just says lump that in with your internal gains. But because those are the same between the standard reference design and the proposed design, there's not a whole lot of impact there on the model. There's just some modeling complexity added there. So that correct answer is the refrigeration equipment. So just a quick overview of the models, just to get a general understanding across and summarize up the points that we've talked about. Things that are common to both Ashrae and Iacc. When you're looking at these models and reviewing them as a code official, you want to make sure that they both have the same envelope and floor areas. You want to make sure they have the same thermal blocks and zoning within the building. You want to make sure that both models have the same location data and weather data, same orientation data. Those can have big impacts on the model's outputs. The same usage schedules for equipment within the buildings, and the same utility rates. So we found a helpful checklist manual for 90.1 and Appendix G that's linked here. Although it's not specifically for the Iecc, some of the specific requirements for the standard reference design that are in Ashrae, but not in the Iacc, and vice versa, won't be covered by this. But as a general review, this might be a good link to follow that you could also use for the Iecc. But we'll try to find, if we can, a specific link for an Iecc review as well. But things that you want to verify between the models that are going to be different. For the Iecc, your insulation values are going to be different between your proposed design and the reference design. That fenestration area is going to be different if it exceeds that 40% window to wall ratio. Your proposed design is going to have more window area than your reference design is. Lighting power densities are going to be different between the two models. The HVAC systems, if it's not one of the 11 specific types that's listed in the HVAC selection tables, then there's going to be that difference between the standard design and reference design. The system efficiencies are going to be different. The capacities are going to be the same. And service water heating, the efficiencies will be different between the two models. Things that you want to find the same between the Iacc and proposed versus reference designs. You should have the same space classifications, envelope roof areas, internal gains as far as receptacle loads, motors, process loads, occupancy patterns, the same ventilation system, the same schedules applied to those ventilation systems and lighting systems. Thermal blocks should be the same between the two models. Heating, cooling, service water, fuel types should be the same, and the capacity of the system should be the same. Going over to the Ashrae models, things are going to be different between that reference design versus your proposed design. Ventilation energy recovery will be slightly different between the two. Equipment capacities, the building envelope R values and U factors. Again, for Ashrae, the assemblies will be the same, but the insulation values will be slightly different. Shading projections will be different between them, similar to the Iacc. Again, that 40% window to wall ratio, if you exceed that, then they will be different. Otherwise, they will be the same if you're less than that. Lighting power densities will be different. The HVAC system type, similar to the Iacc. Here we're calling out that refrigeration equipment again. If it's not in that table 6.8.1-11, then they will be different between the models. Otherwise, they will be the same. Roof albedo, the darkness or brightness of the roof will be different between the models. Ashrae lets you account for that difference in roof color as far as the impact on the cooling loads, and air leakage rates will be slightly different. Mainly because what we're looking at here is as you're modeling the process, your proposed design is going to have that target air leakage value that initially is going to be matched by your reference design. They're going to be the same. But as you complete your construction and do actual testing on the envelope that's required in the Ashrae standard, then you're going to be adjusting that proposed leakage rate to what it actually is in the building. So you can account a little bit for the savings there. And then as far as the things that are the same between those models, mechanical ventilation rates, the economizer usage setup, space use classifications, envelope areas, schedules, although we will note in Appendix G, you can make some adjustments to scheduling of equipment that get you a little bit more savings. Similarly, for motors and orientation of the building, Appendix G allows you to take credit for optimizing orientation and motor performance, where the standard cost budget, they will be the same between models. But then thermal blocks, service water loads and needs, and receptacle and process loads. Those will all be the same between the reference design and proposed design for Ashrae. And then, Ryan, was I handing it back to you for the last section, or continuing through? I can't remember.
Yeah, as far as when we're choosing a path, now that we've kind of talked about where these are the same and different, what's perhaps going to lean us one direction or another. So with that, the Iecc, as we touched on earlier, the proposed model does need to beat the standard reference design by at least 15% in order to account for those additional efficiency options that are found in the prescriptive path. So this is something where that 15% is not found over in Ashrae. The proposed model just needs to be less than the reference design. So if you're right on the, you think you're going to be on the bubble, and all you're trying to do is just squeak by the skin of your teeth, then maybe Ashrae might be a more likely path for you. Iecc, looking at, again, trying to say, well, if I'm trying to provide good value, I might be over that 15% anyway. So that might lean you one direction or another. Also, the Iecc, generally the modeling is a little bit more simplified. We did touch on a few aspects where Ashrae is a little bit on the more simplified side. Iecc, it does allow you to group the thermal zones a little bit more easily and readily. So that may lean you towards the Iecc. Also, as Sean had touched on earlier, those reference design requirements do allow you for more to take advantage of better envelope practices. Some of the ones that we had touched on were things like, if you go ahead and put insulation on the exterior to take advantage of and utilize the benefits of that thermal massing. Also, if you use wood frame construction or wood studs rather than metal studs where allowed, that can be beneficial in the Iecc, whereas Ashrae doesn't allow you to take advantage of that material change. Whereas Ashrae, the reference and proposed designs are a little bit more closely aligned, and it also that particularly does allow for much more flexibility, again, with those exceptional calculations. So if you're working, if you're using a performance program that's a little bit more limited in its capability and you're needing to do more exceptional calculations, then Ashrae would probably be more the bent that you would go for that. Also, Ashrae does allow for a little bit more credit for variable speed fan systems, understanding that most fan systems out there are becoming variable speed. So that may lean you that direction. And just touching briefly on Appendix G. This is, as noted earlier, this is something that Ashrae has, that there is no correlation in the Iecc. Appendix G is a little bit different in that it is a dependent model based on the characteristics of the proposed building model, whereas the energy cost, the standard performance is on an independent model. So here noting the independent model has a much more stable baseline. So rather than the baseline being changed with each cycle, it uses a standard baseline and then says each cycle you have to be a certain percentage better than that, and each code cycle that increases how much better you need it to be. So these also can take advantage of practices that may be highly beneficial, but perhaps not as common. So designing better than common practice can also be useful in Appendix G. And as noted earlier, this is commonly used for if you're doing a lead project. Appendix G we see much more frequent there. So, with that, I do want to thank everyone for participating today. I will hold here a moment or two. If anyone else has questions, they want to pop in the Q&A box. But if you think of a question later that it's like, oh, I should have asked, or you're needing some technical support for the International Energy Conservation Code, specifically for projects here in the state of Illinois, or on Ashrae 90.1, feel free to reach out to us, energycode@illinois.edu, and do have our toll-free number if you need. I'm not seeing any questions coming in, so again, want to thank everyone for participating today, and look forward to seeing folks in the new year at our next upcoming workshop in January.
Thank you all for joining us today. Have a wonderful afternoon.